2009, Afghanistan. A NATO Chinook transport helicopter is struck by a Taliban missile. The chopper falls 110 kilometers from a military base in Kandahar and catches fire. The crew are evacuated by a rescue team, but the Chinook itself remains lying in the sands of Waziristan. And here, mainstream politics comes into play. An American helicopter isn't considered down so long as a large part of it can be delivered to a repair base and restored. While sometimes these repairs cost far more than a new chopper, they work like a charm for decreasing loss reports. Two other Chinooks attempt to lift the down chopper, but to no avail. And then the Americans swallow their pride and resort to an unconventional solution. They call for the aid of the strongest heavy transport helicopter in the world, a true monster of the skies, the Russian Mi-26. Escorted by NATO Apaches, the Russian air truck transported its main Western competitor to a repair base without breaking a sweat, once again proving that it is the most powerful helicopter in the world. The Mi-26 is the largest, most incredible helicopter capable of lifting the greatest loads. No other country has been able to create anything of its kind. This is a very Russian helicopter. After all, it came to be thanks to one of Russia's eternal torments, bad roads. During the Cold War, nuclear missiles needed to be delivered by some means or other to faraway launch sites in Siberia and the northern Urals. The simplest way to solve this issue, and simultaneously the most complex for designers, was to create a huge helo behemoth.
The Mi-26, NATO codification named Halo, crew 5 people, maximum load capacity 20 tons, length 40 meters, rotor blade diameter 32 meters, maximum speed almost 300 kilometers per hour, service ceiling 6.5 thousand meters.
It was created exclusively as a transport and assault copter for the military. But recently, its peaceful modification, the Mi-26T, has become simply indispensable for a whole host of installation and construction works in hard-to-reach places. Wherever a super strong flying vehicle is needed, the monster Mi-26T, a super helicopter, comes to the aid. On the main slipway, all the individual parts of the machine are joined to each other. The cargo floor of the side, the tail boom. In about 2 weeks, all the parts, just like the pieces of a huge three-dimensional puzzle, will combine into a single whole and turn into a completed fuselage. Afterwards, the body is rolled out, and they begin to piece together the next machine on the slipway. Here, at the so-called non-slip stage of the assembly, the helicopter's body comes into fruition. Several dozens of thousands of additional rivets are fitted, doors are hung, and the internal partitions are installed. Basically, you end up with an almost finished fuselage. The only thing, as you can see, is that it doesn't have a head yet. That will be attached to the body of our monster a little later. This is done to ease transportation of the fuselage from one workshop to another. Let's not forget, the head of the Mi-26 weighs a hefty amount and is also the most important part. Like with a person, all the control systems of this huge machine converge into it. Almost the entire helicopter is made of very thin and light aluminum, but it still weighs 29 tons and carries about 10 tons of fuel. It's no surprise that this monster is one heck of a gas guzzler. For example, do you know what this is? Nope, it's not a door, but a hole for the exhaust pipe. Everything about this helicopter is very large. In turn, the engines that must drive it are also huge. The decision was made to position them in the upper part of the hull and carry them forward a little to balance the considerable weight of the very long tail boom, which was forever attempting to rear the helicopter. Here in this area, in the upper part of the fuselage, are these flaps. They're called hoods. The same name as a car hood is used here because under them will be hidden super powerful engines, each packing 11,500 horsepower. The power is enormous, but it still needs to be converted into the very lifting force that keeps the chopper in the air. It turns out that the monster helicopter needs a powerful main rotor, the largest rotor in the world. The MH-47E has a single rotor design, meaning the entire load isn't distributed over two rotors, like for example on the Chinook, but falls on the shoulders of 8 giant blades attached to the main rotor transmission.
Mikhail Leontievich Mil once said that if there are new blades, then there is a new helicopter. So, these blades were created to replace the Mi-6 helicopter.
Each blade on this monster exceeds 50 meters in length. They differ from the screw wings of the previous Mi-6 not only in size, but also in design. For the first time ever, a production technology based on composite materials was employed specially for this helicopter.
As we know, the whole world is now switching to composites, as composites are more reliable than metals. Metals are prone to corrosion, and the durability characteristics of composites are often higher.
The beating heart of each blade is a titanium longeron, or as it's called here, a pipe. Once it arrives at the helicopter factory, it's meticulously polished on grinding machines that have been specially designed and manufactured for this operation. The longeron is polished to perfection using bog-standard metalwork sandpaper. The process takes 5 days, and during this time, hundreds of meters of strips like this are completely scrubbed off. But in the end, the surface of the longeron becomes so even that you can look at yourself in it, like a mirror. After polishing, the internal stress of the metal is removed from the pipe. To do this, the entire longeron is tapped with small metal balls. After this treatment, the entire surface of the pipe is equally stressed, and the likelihood of cracks forming is significantly reduced. Parallel to this, the so-called plumage of the helical wings is gathered at the blade plant. A little later, it will be joined to that very titanium longeron. The blade is only hard on the outside. Inside, it's filled with porous material. This here is called a cell block, but it's really just paper infused with a special resin. However, since this paper is assembled into a structure reminiscent of a honeycomb, the block turns out to be incredibly durable. The honeycomb block is covered with textilite, coated with epoxy resin, and sent to the oven. After all the materials have sintered into a single hole and hardened, the finished segment is glued to the longeron. As a result, this means that one blade consists of 26 such segments. They withstand colossal loads, for they must generate enormous lifting force. But surprisingly, thanks to their cellular structure, they are incredibly light. This complex composite segment weighs only 1.5 kilograms. The finished blades are sent from the workshop directly to the airfield. They're hung on the helicopter at the very end when the other parts are finished. Meanwhile, the installation of the main systems is completed in the assembly shop. The fuselage is finally joined to the cockpit. The engines are installed under the hoods. The installation team and electricians attach thousands of wires to the dashboard and solder tens of thousands of contacts. Afterwards begins the long and grueling process of fine-tuning the equipment. The huge machine should respond to any human actions just as organically as a violin responds to a musician's bow.
We bring things to life. We're like doctors. We listen, we examine, and I always have my own slogan that our work is the work of why, meaning that every time, every day, I do the same thing again and again, but I ask myself, why is it working this way today and not like it was yesterday?
Bringing a helicopter to life takes several weeks, during which possible hiccups such as system errors are discovered and fixed, and meticulous work is performed on every single block, along with every soldering contact.
All right, Vanya, look, I didn't get a spike in AC mode, so could you please jump into the cockpit and turn on the range on the transponder control panel? Turn on AC mode. I'll give it a test from here, and if it works, I'll give a signal, okay? All right, great. Okay, let's go. Let's be quick, okay?
Yevgeny Vlasov has revived more than a dozen Mi-26s. Surprisingly, all the helicopters behave in their own way and have their own personality. Each monster has its own whims and shortfalls, which Yevgeny corrects on Earth, before the monster takes to the sky. Here, being a great electronics engineer doesn't cut it. You need to have instinct and intuition to understand what is going wrong in the kilometers of nerve endings circulating through this huge machine. It's a difficult job.
Of course it's difficult. It's very difficult. It's very difficult, and what's more, it's a complex combination of simple devices that are simple at first glance, and then the transition to very complex circuit technology.
On top of that, this circuit tech is constantly being improved. More and more new instruments are installed on the chopper that are lighter and more accurate than their predecessors. The transition from light bulbs to semiconductors alone shaved off hundreds of kilograms in weight. The only part of the Mi-26 fuselage that isn't made of duralumin is the nose cone here. It's made of textilite and coated with what's known as radio-transparent paint, and all because a very powerful weather radar is hidden under this cone. Its radius of action is 300 kilometers, and it's so powerful that, for example, here in the workshop, turning it on is strictly prohibited. It can fry all radio electronic devices. After installation is complete and all operation systems have been checked, the helicopter is handed over to the test pilots. It takes about a month from the moment the sheet casing is anodized till the vehicle is rolled out of this hangar. In fact, if you put a Boeing 737 passenger plane next to this monster, the helicopter will be longer. When you stand on the helicopter, you begin to realize that it truly is a monster. Its length is 40 meters. And by the way, this is the only helicopter in the world whose tail boom you can safely walk along. But is it safe? It's a little scary for sure. After all, the height here is about 5 meters. This Mi-26 transported the cargo to the faraway drilling site in Ugra right on time, meaning that consumers will receive their oil bang on schedule. Thanks to these timely efforts, gasoline will appear in our cars, public transport will operate, and petrochemical factories will issue their products without interruption or delay. The Mi-26 is one of those monsters that holds the modern world on its shoulders, that in every sense of the word, raises our standard of living.